So nice. All right. So let me all introduce myself to all of you. This is MC Bhavya, sweet, energetic, and entertaining voice of an audience. It's my glad time to be the host of this event today, and this program is powered by DataStax, right? As we all know that DataStax is a wonderful real-time data company. Looking at all of your faces, it really ensures me that you all are very much aware and impressed by their services. But still, let me take an immense pleasure to introduce them. With the data stacks, any enterprise can mobilize real-time data and quickly build the smart, highly scalable applications required to be data-driven business. With Astra DB and Astra Streaming, DataStax uniquely delivers the power of Apache Cassandra and the world's most scalable database. With the advanced Apache Pulsar streaming technology and an open data stack available on any cloud. Hundreds of the world's leading enterprises, including Version, Audi, ESL, gaming, and many more rely on data stacks to unleash the power of real-time data to create in the moment digital experiences that can win new markets and change industries. Why don't we clap for them? And in the meantime, I extend a warm welcome to the DataStax team, and I request please stand up and wave your hands for our audience today. Thank you so much. And for this event, our sponsor is Intel. Intel is a technology industry leader using collaboration, co-engineering, and open source contribution to accelerate software innovation. Intel software connects millions of developers to develop the evolve new technologies, helping software and hardware work seamlessly together. In this talk, Intel will share some contributions it has made to Apache Cassandra that will greatly increase the performance and resource utilization. Come on, once again, huge round of applause for the Intel for our sponsor. And we all have gathered under one roof, right? So what is that for? Today is the Astra Day. DataStack is celebrating Astra Day. So what is it all about? Let's we all allow ourselves to educate and learn more about real-time data and cloud-native applications with the Astra DB, including change, data capture, and streaming. Learn how enterprises mobilize real-time data and quickly build the smart, highly scalable applications required to be a data-driven business. And we have the wonderful team here from DataStax. Let's be all hear from our fantastic lineup of speakers on how Astra has helped unlock the power of data in real time. So once again, I extend a warm welcome to one and all present here on behalf of DataStax with a huge round of applauses. So firstly, I would like to request Mr. Rajiv Kapoor, Area Vice President for India and SAARC, to present the welcome note. Ladies and gentlemen, I request everyone to be very energetic today.
Good morning, all. A warm welcome on behalf of DataStax team. I know it's tough to come in time in Bangalore traffic. Thank you for braving Bangalore traffic and being here in time. My colleagues, I also thanks my colleagues who have come from Singapore abroad and to be a part of this session today. And please feel free to mingle with us. Our team is around DataStax. They have a batch of DataStax wearing. Any question, queries, and doubt, please meet up with us. I'll be more than happy to answer your queries. Enjoy your day. I'm sure that you're going to learn a lot today. Thank you so much. So next, back to you.
Thank you, Mr. Rajiv Kapoor. All right. To present the wonderful keynote, State of the Data Race, there's a wonderful gentleman out here. That is none other than Mr. Henry Isaac, Lead Cloud's native DataStax. Ladies and gentlemen, put a huge round of applause to welcome them on the stage.
Wow. Uh, I'm so thrilled coming to Bangalore. I'm based at Mumbai because this is a city of startups. This is a city of technology. And I was told that when you walk on the streets of HSR, you get a new idea of how to start up, how to start a startup, right? So I keep walking. I actually never got an idea, but probably I got, but I couldn't execute. But it's all about speed now, right? And across the room, I was talking to a few gentlemen. A couple of things that came up. Uh, People know technology. India is building some awesome products. We are in the I think top in terms of the technology, right? Earlier we used to hear people moving from India to going to US and building something there, but very glad to the government and the policies and all of us building something awesome in India. Let's give a big hand to ourselves. Yeah. And I see a phenomenal change in the mindset. When I talk to the CTOs, it was always about build versus buy. People used to build, but now they are buying. You guys agree? What is scarce is, while we have awesome developers, I think productivity is the key. Agree? And speed is the currency, right? And data everywhere. Data everywhere. That's the new oil. Yeah, no data to use. That was something that we heard, but I think that's tripling. Data is tripling. As the new technologies emerge, as the new things come in, right? So earlier we were all coming from the dinosaur days where we used to go to the bank. It was machine to machine or human to human, right? Now it's human to machine. And what happens with that is the real-time data, right? So next slide, please. Can I move this? So we have done some surveys, and most of the respondents agree that their revenue is directly related to the real-time data. There are many examples, right? For example, if you go to Make My Trip or any other thing, right? And if it takes more than 15 seconds or 20 seconds or even a second, you'll move out. So, or companies like Netflix who have done it so very well that you get a recommendation very fast, right? Or you look at a Flipkart or a Myntra who very quickly give you like, hey, this is the price, this is the offer going on. So it's all about like, how do you get the real-time data? So we have seen that these responses have been awesome. Next slide. Yeah, and we also seen that uh, there is a direct impact on the revenue, right? So today everybody is like, earlier I used to hear statements like conserve the forests, conserve the tigers, right? We still have to, but you know what I hear nowadays? What is that? What is that? Not data, revenue, something close to revenue. It's all conserve the cash, right? At an individual level or at an organization level, I think we are all going through a time when we need to use the cash that we have in the most effective way, right? I'm not here to give you some tips around those. There are separate sessions, but definitely conserving that thing and how can it impact on the revenue? Every dollar that we spend on the technology, how does it respond? So we have been seeing that 42% have definitely told that it's directly impacting the revenue. One is the growth, second thing is the revenue, and also that like there are few companies who don't prioritize on that, which is fair enough, right? I mean, we cannot have everyone in this whole race, right? Life is a race, right? Everyone agrees? And even if you win it, it's a rat race. Yeah, so, but in this race, we have to be successful, and as we go, we see more things happening. So, very important stuff that's happening around is around the developers, right? Because, like, earlier people used to talk about developing nations and developed nations, but now it's developers nation, right? It's all about developers. It's all about how can you ensure that while their productivity is good, how can you give them things that are very simple to use? And they have felt that technology is more exciting than ever, right? I come from the days when I've seen the mainframe, blue screens, right? But I don't think my kids love it anymore, right? And we all are actually now looking at that. Technology is at an awesome pace now. And more partnerships are happening amongst the technologies, working together. You don't believe that we built Cassandra 4.1, which we released last year. The version was built along with the industry team. The developers in the industry and we from DataStax together worked on that. So this is really an awesome time, right? Especially excited about the technology that's right now there. And I don't think there is any other time because now there is some market correction, there are some changes, but nothing to be worried. People who are technologically strong, who are going ahead, they're all re-looking at their products, building it, and developers are the key. Developers are definitely now seeing that, like, real-time data is something that, like, how can they also leverage that, right? So as I told you in the beginning, there is data everywhere, but somewhere we see that it is the inertia, right? It's in silos. It's somewhere lying below the hood. It's not like, working together as a complete one organization stuff. So we are seeing that the developer productivity also has improved because of various stuff. One is you get easy learnings to be done. There are so many honchos of the world who are sharing their experience. And earlier days, like, we just go to Google, start doing something, cut and paste, and it works, it may not work. But now there are some best practices. There are blueprints available, and there are companies like DataStax and others who are contributing a lot to this open source and seeing what can we do the best for the developers' productivity, and they're going ahead. I would recommend that you should all read this Data-Driven Enterprise of 2025. It's a very good article by McKinsey, where it really talks about how by 2025, we are talking about human to human, machine to machine. How do humans and machine work cohesively in a very structured manner is what they are predicting for 2025. I would definitely recommend you. And there are some 7 characteristics that they have given there. And what it all talks about is that how can this work in, like, in tandem? And how can data, like somebody told, it's a new oil, it's plutonium, right? If you use it properly, it's awesome. Otherwise, it blows it up, right? So we all know that. So how do we now probably more value will be given to the chief data officers, right? I don't hear any database administrators now in the world, but it's all about, like, the developers, like, and how do we now bring this whole power of data, like, without having the security concerns, without like, the compliance that are going on in the country, and how can we be ahead of this whole race, right? And that brings a huge stuff, but I would recommend, I can give you the link, I can share this. Yeah, just this. So these are the three problem statements. You may agree to disagree, but I'm happy to speak to you all guys during the tea break. I'm available, right? So with 2.5 decades of working in the India software solution industry, I was a part of the team which launched database as a service at Oracle. I worked for Salesforce. I worked for many companies, but now, what problems I've seen over a period of time is data somewhere is not getting leveraged the way how it has to be done, right? It's lying somewhere. Multiple applications. Most of them are application-centric kind of model, and then below that there is a middleware, and below that is a database, right? And the other teams don't get an access to that. And multiple versions of data. Data is moving all over, right? And I personally feel that data should not be moving because, again, it's a plutonium, right? You should be very careful with that. So everybody agrees with this problem one? Anybody disagrees? Agree? Thank you. Second one is compliance and the security, right? It's very easy to dump data, right? I mean, I don't know how you can flush it, but yeah, I don't want to use words there. Yeah, so, but everyone dumps the data, but all the problems now come in the security issues, right? Example, like, multiple versions running around, and then, like, not properly, the code is not tested, or the statements which were used is not working in. And the only thing that comes in is the new, ever-changing new requirements, right? India as a country, as we are bringing in more and more, like, flexibility is required to change it, right? So if you are sticking on to a very rigid model and not a flexible model, it becomes very difficult, right? Especially you are stuck on the premises, or you are stuck with some particular cloud provider. How do you move it? It's not a joke, it's not a magic wand, but maybe the management will come say, hey, there's some funding coming in, so please move there. Or, or the whole industry is moving there, so let's move there. So it's not that easy, right? So how do we now move on to meet the compliance and the security requirements? This is one more problem statement that we have looked at, and we are trying to solve along with the industry and developers like you. Third thing is that how can we be faster to the market, right? Because as I was telling you, right, maybe even if I start something now, something tomorrow evolves, and then this yesterday what I was working was over, right? It's actually a grand new stuff that comes into the field. So how can we, like, and again, it's little related to the like productivity. It's also related to the Kubernetes-based or a microservices-based technology that you build, and on top of it, how do you adopt some models by which you are very, very fast to the market, right? If there is some small change that comes in, how can you bring in some AI ML modeling? People talk about AI ops, right? But I really not seen it happening, right? People talk about Web3. I still see it's not reality, right? I mean, we are doing it in some part or the other, but how do we now add all this together, which will again now run in the khichdi or what we have already cooked, right? So that is also key, like how we do it. So these are the three problems next. So what we have done is that there is an inertia in the data. Data is good by itself, but applications generally own the data. Agree? Sometimes I meet few database administrators of the data team. They actually don't know where the data comes from and where it's going, right? So, but that inertia is still there, right? So second thing we have seen is the movement is very heavy, right? It's very difficult. I know people who are doing it or faced it will talk better than me, but that is something that we are seeing as and integration with between the apps. I think we are definitely heading very well there with the API layers coming in. A lot of companies working on it. So I still see a lot of improvement in the consolidation piece. But the third one is again we are so comfortable, right? Anything to change, man, who will spend another 2 hours extra? Why should I do it? I'm already very happy, right? Unless there is a bamboo, sorry, what do you call it? Unless there is something coming in, and then we all run behind it, right? I feel that we are still playing a mid-school soccer, right? Soccer, FIFA. There's nobody at the goalpost, but everybody are running, right? So, so I think sometimes the whole organizations are now looking at this change. How can I have this legacy move bits and bits to the ever-evolving stuff? So with this, the next one. So just go more faster. So we have seen that the solutions is, if you want to bring in agility, it's all about unifying the data, right? And I'll come to the slide next one, just next. Keep this. And empower the developers to build applications, right? So we are very happy, guys, who are in this room. If you want us to do a 2 hours workshop at your place, look at your data model, engage with you, because this is all a team effort. It is a partnership, right? I don't believe that any company today who comes in and says that, hey, this works and one size fits all, don't go by that. I at least don't go by that, right? It's all about how do we collaborate. We have our engineering leader who's going to come in next and speak, Venkat. He comes with a lot of experience. So he's going to share his experience of how he can partner with you folks and probably do a 2 hours workshop. We'll not give our point of view saying that, hey, this is wrong, this is right, but we may get to learn from you. And if you want anything else that you want us to run it for you, we are more than happy, because 90% of the global top 100 enterprise depend on us, whether it's Netflix, Spotify, Apple Pay, you name it, many more. Even in India, we have many. We're doing very well. And then how can we decide and act in real time? So this decision making right now is not data driven currently, but in 2025, I think every decision that's made is not made in the boardroom. It's going to be data driven. Trust me, it's going to be data driven. So we are now preparing the models that we have so that these are all and how can we offer data as a service, right? So we have heard that data always actually has been a cost center, right? How can we make it as a a profit center? How can a data be given as a service? How can we looking rethinking this whole data is not just that, hey, when somebody wants a report, I'll put somebody and then give it by tomorrow, right? So how can we self-enable them and then ensure that the data is available? Next. So this is a model that we generally now look at. Most of the companies, enterprises, startups, they first look at an application and then somewhere below they'll choose a data. Agree? Silence in the room. I say it as agreement. Yeah, and again, like, we are looking at the right side thing is the deep lane, and the left side is the fast lane, right? So DataStax and companies similar to us, they work in the fast lane. So don't confuse between a data warehouse, which is a deep lane, and this is a fast lane where we talk about the real time. Yeah. Now we are looking at the new model where data will be like, the top layer, and then where you get all the features of availability, your scalability, your security, where you want to do, what you want to do. And underneath lies the application. One application can be an end user customer for you, but the data should be the chief data scientist or the data team or the data platform team in whatever avatar that you talk about, right? So they will be owning it, and then, like, even at the deep lane, data will be leading there, right? And then it, like, pipeline and the application which will live. Looks good? So this is what I think now India is transforming fast, and I think in India, Bangalore is the first to do that, right? I'm very happy when I'm having conversations with a lot of leaders here. We are partnering with them in bringing this change. And once this change comes in, if you go back to the previous slides, it will cover almost all. So what are we now bringing to the table, right? This question, if somebody asks you in an interview, you know what is the right answer? What do you bring to the table? Actually, you should say, I bring the table itself. Yeah. So what here it talks about is how can we have a data store which is open, which is available on all the main service cloud providers, the cloud service providers who are like available in the market. You are flexible to move from one to another. It's very easy to do that. Don't get locked, right? I don't want to use some heavy words here, but we are seeing that how every company is now looking at how can I unlock myself and be little free, flexible, right? Because in the beginning you may get some shops and there may be a better pricing, but next year when it goes up, then you end up building a lot of internal, like, workflows and all. So we are now trying to see how this data model, like, with all the technologies that are mentioned, most of them are open source. They are built by us. We build it and we open source it. Whether it is Stargate API, I think my colleagues will talk about it, that talks about the APIs that we have built. Stargate has been really well adopted by the developers. If you guys have not tried it, please try it out. And this should be able to support all the applications and should be able to give the data that's required for your AI, things like those. So this slide is pretty readable, understandable. This is available on our website as well, or I'll share it with you. Yeah, the next. All right, so this is the trend. I mean, don't get scared, but this is the typical enterprise when I say that there are multiple products, multiple platforms, multiple geographies, multiple system of engagements, multiple, social media channels that are available. But when any leader looks at, he feels that it's very simple. The data comes from here, it goes there. No, it actually takes a lot of shape around it. And we have been helping many companies build this. We are very, very strong in looking at how we can bring in a data model which can support any kind of database that you're looking at, and what matters to you mostly is the latency, right? So how can we help you in building those efficiencies and having one data as the center point of it, and rest all revolves, and rest all consume the data. I think that's what I've got to speak today, while I can talk for hours and hours more. Ladies and gentlemen, thank you so much for this opportunity given to me. And
Mr. Henry, as the keynote was really persuasive. Dear ladies and gentlemen, once again, huge round of applause for Mr. Henry Azad. Thank you so much. And there's one more wonderful speaker for this day. So, access real-time data anytime, anywhere. And the speaker is Mr. Venkat Lakshmi, Lead Engineer, DATASTAX. Ladies and gentlemen, please give him a huge round of applause.
Quick audio check. Am I coming through? All right. Okay. My name is Venkat. I'm the engineering lead for DataStax. If we could please move the slides. Right, just quick show of hands, just a couple of questions. How many of you on a day-to-day basis are concerned with the technical aspects of data, performance, functionality, and so on and so forth, from an engineering point of view? That's quite a lot. That's about 50%. How many of you are concerned with administering data? The reliability engineers, production engineers, SREs? Okay, few of you. And how many of you are concerned with the business aspects of data, right? I'm not necessarily saying that these are isolated. Some of you could be doing all of these, but right. So as you can see, right, Henry set the stage basically talking about how relevant data is in terms of making decisions. I just want to basically dwell on that a little bit further, but before I do that, I mean, my position is right? You're able to see the screen, there's no problems, right? Okay, cool. So what I want to quickly do today is share what we've learned from our experiences having deployed Cassandra and Astra DB onto a number of different landscape of industries, right? So these industries span from the top enterprises, the top 100 Fortune companies to startups and so on and so forth. And as we've done that, we've been able to arrive at a certain model, for basically for enterprises and other businesses to be successful in creating value with data, right? So that's what we've been able to do. I want to share that, but at the same time, I also want to see if we can get feedback from you on, right? So that's the purpose. If we can go to the next slide, please. So digital transformation, it's probably the biggest cliche ever, right? But it is a cliche for a good reason, because it's apt, right? Because there is a transformation happening in the digital space, and that's going to continue to happen for at least the foreseeable future. But the more important point out here in this particular slide is that as we go through our motions, right, what we are fundamentally trying to do as different businesses is we are trying to create value for our users, right? And you basically, when you're a startup, one of the first things that you do is you put data at the center of those decisions. Henry spoke about this in a lot more detail. I won't dwell on it. But what does that actually mean on the ground, right? So it's not just about saying, okay, I'm going to have data, in terms of my decision making. It's about being able to store the data, make it available, scale that data, analyze the data, weed out what is the potential use cases that you can get out for your users, and then implement those use cases. For all that, you want to be deploying, right, your talent pool, your technical talent pool, your business talent pool, and put them through that thought process, right? Your talent pool should be thinking about what is the different kinds of data that's flowing through my system, right? What can I benefit from it, right? And that's how, we'll speak about a Netflix use case, recommendations and stuff like that that all of you are aware of. All those things come from a conscious effort to look at the existing data and then trying to figure out, what is this data telling me, right? What is it telling me about a user? What can I do to basically provide more value, right? So if you're doing that, and if you want to concentrate your talent pool towards that, then you want to basically look at typically a managed service, right? You're basically looking at deploying your data solutions as a managed service. The reason you want to do that is, again, going back to where you want to concentrate your talent pool on, right? So you start thinking about cloud native, serverless, right? When I say serverless, most of you are thinking Lambda functions, right? And most of you are thinking, hey, this is something that I can leverage directly from my code. I write a function, I'm able to, boot up this particular infrastructure. I write a function, I'm able to basically create an application with it, and so on and so forth. So what serverless gives you is the ability to sort of have your application developer basically use infrastructure, and therefore extensions of infrastructure, things that are deployed on top of it like databases, as a function, right? So you can deploy that, and it gives you that flexibility. And the last thing is AI/ML, right? How many of you have been reading up this news about ChatGPT? Show of hands, please. Right? Crazy, right? It's really mind-boggling what ChatGPT can do. In fact, as Henry was speaking in a little bit earlier in the morning, I was basically looking at a wonderful use case where actually they're using ChatGPT to basically point towards a code base, any code base, application code base, and then tell you what the errors are in that code base, right? Think about the implications of something like that. You can actually give it your source code as an input, and then you get basically the errors back, right? So that's where the whole ML and AI space is evolving in terms of understanding natural language. So you want to be able to leverage that. You want to get data real time. You want to put it through the systems, do the transformations, understand where it is, and so on and so forth. So you need something that basically covers these tenets or these aspects. When you're thinking of a data solution for your companies, right, you want something that actually covers this. And you want to be thinking in this way, because if you're not doing this, then you're most probably going back to thinking about in the older fashion in terms of your decision making. And I'll speak a little bit about that in the next slide. Next slide, please. right? So if you look at how decision making was done organically before, right, or historically, when we decide to, put out a new feature, what we used to do previously was we used to do a market survey. We used to do some anecdotal random sampling of people saying that, oh, these are my biggest customers. Let me go and ask them, what they need, and then I will make a decision based on that, right? Turns out, interestingly, is that there is a relationship between the number of users your application adds and the value these users create for you over a period of time. Now, if you were in the traditional mode of thinking, which is whatever it is, what I spoke about, market survey or random sampling, over a period of time, irrespective of the number of users you add, the value peters out, right? It just goes high for some time and then peters out. But if you basically look at data-centric decision making, where you put data as the center of stuff, understand your data, understand what it's trying to tell you, then you can basically see that as the users scale, the value also scales, right? So that's the advantage of putting data, at the center of things. And I think Henry said a wonderful thing, right? He said something like, decisions are not going to be made in the boardrooms anymore. Decisions are going to be made by people like us because we are the ones looking at data, right? And that's going to speak louder than anybody's intuition can, right? I'm not saying we're going to eliminate intuition, but it's going to be a combination of intuition and data. So that's where it is, right? And then take an example of Netflix, right? There is this thing called the virtuous cycle of data, and this should be pretty intuitive to all of us. So let's say we continue to add more users. That's going to drive more data through our systems because there's more users, you're going to have more information. That's going to force us to come up with better and better algorithms to try and understand what those users are doing so that we can create value for them. And then once we have better algorithms, we better provide a better service, and then it becomes a cycle of information, right? And as you can see, each of these phases are sort of interacting with each other, or in affecting each other interchangeably, right? So this is something, if you take most of the decisions around Netflix as an example right now, right? I think, as you can see, they're going away from a subscription-driven model to an ads model and so on and so forth. And when you do a paradigm shift like that, you need to understand your user profile better, right? You need to basically leverage that data. It's not just going to sit in your data warehouse. You need to analyze that, right? So that means that you're getting into this vicious loop, right? And this is common through any high-growth app that you can think of. In fact, we speak about a few use cases, but just leverage your own experiences of the apps that you use, and this should be pretty intuitive, right? So just to go back to my fundamental point from the slide, if you're making data-centric decisions, the value will scale with the number of users you add. If you're just going to rely on intuition or traditional ways of thinking about creating value for your customers, at some point in time, it's going to peter out, right? It's going to just become stable and so on and so forth. So that's what I'd like to leave. Next slide, please. Okay, so I spoke about, Netflix. I mean, other examples are Apple, Spotify, Starbucks. These are some big customers in top 5 Fortune 500 companies that basically leverage Cassandra, Apache Cassandra. But this slide, the reason we want to basically talk about this particular slide is that it's not limited to any specific sector. It's not that it's a fintech play. It's not that it's basically a social media play and so on and so forth. If you look at the range of different sectors that are covered here, it's pretty versatile. You're starting from logistics and asset management, which are traditionally what you would consider brick and mortar businesses, right? You're talking about real-time payments, which is a cloud-native business, right? Or a digital native business, because that's organically technology-based, right? So you see the versatility in the kind of industries that are actually leveraging Cassandra to basically create value, right? So 90% of the Fortune 100 depend on Apache Cassandra. I mean, that's a pretty assertive statement, right? They depend on Apache Cassandra for making these decisions using data to create value for their customers. And these customers are as varied as you can get, right? There's a fundamental difference in the kind of customers a logistics and asset management company would have compared to a digital delivery company and so on and so forth, right? So just wanted to basically point out the versatility of Apache Cassandra in this whole data space as such. Next slide, please. Cassandra, I'm going to repeat the question that Andy asked. How many of you have either worked with Apache Cassandra, learned Cassandra, or use it in your current solutions? Okay, well, that's a good sizable number. That's a good. So really glad to see you all, and then, I'd love to talk to you people offline, right? I just want to understand your experience and so on and so forth. But for the rest of us, and even for us, the rest of us who've used it, just a refresher, right? I mean, these are table stakes. If you don't have this, you're not going to go to any database solutions. It has to be highly available. That's not even a choice anymore, right? It has to be available, all the time. Linear scalability. None of us, irrespective of how good our models are, our mathematical models are, can precisely extrapolate the number of users you're going to add over a period of time, right? So this has to be figured out by your system that you're using. It has to have close to linear scalability that will help you achieve hyperscalability as such, right? Think of all the popular apps that we've launched out from India. They've gone from nowhere to millions of users in a very, very quick time. And that's a very tangible solution, especially out here in India, where when you're creating a solution for the consumer, you're typically creating it for billions of people, right? So that, and billions of people using it all the time, right? So this is, again, it's a non-negotiable aspect of database management systems. Low latency, I don't have to mention that, because most of these applications, hyperscalers, typically tend to access data real time, right? So when you're at that point in time, when you're accessing data real time, you cannot have to, afford to have. Think about a stock market application, right? It's as real time as it gets. You cannot afford to have latency this thing. I mean, think about, I don't know, why does WazirX come to mind? Yeah, WazirX, right? Crypto exchange and stuff like that. Imagine if you're seeing the value of Bitcoin a minute later than it should be, right? Instead of the next few seconds. So latency is something that is non-negotiable. Global distribution, again, a lot of these solutions that we're building are not limited to India. You're going to be deploying it across the world. A classic example from my previous company, GPay, I'm not sure if you're aware, the Google payment system was actually developed, conceived from here in India, and then it was taken to the world, right? It's never, if you look at other solutions from Google, whether it's search, YouTube, ads, or whatever it was the reverse direction, right? It was the world created it, US created it, and then it came down here. But this is a completely reverse direction as such, right? So what we are building in India, please rest assured, is going to be relevant to the rest of the world also. And when you're thinking about it, think about it that way. Think about your solutions that way. So global distribution, as you scale, will not be a choice anymore. All of these will be fundamental data stakes, table stakes, sorry. Right. Next slide, please. Yeah, so it's our responsibility to sort of give you both sides of the pictures. A lot of you are Apache Cassandra users, right? And some of these will resonate with you, right? I'm pretty sure some of you have had issues operating Cassandra, right? Show of hands again, issues, all right, cool. Monolithic application, right? When I say Cassandra, what are the 3 or 4 modules that comes to your mind? Coordinators, writers, readers, compactors, right? The implementation is basically one monolithic Java process, right? So it could well be that you're seeing a performance problem, and it's really a compactor that's not doing your job. But at this point in time, you basically have to scale the entire Java process up, which means you scale your readers, writers, and so on and so forth. So you need to modularize that. That is a genuine concern. And all of these have come down from feedback from the market. The other aspect is API flexibility. How many of you use drivers for accessing data? Okay, cool. Pretty sure it's clunky, right? Drivers are difficult to implement, difficult to maintain, and so on and so forth. What you need is for real-time access is API flexibility. Either a REST API, gRPC, GraphQL, whatever it is, right? It could be any data model, but you need that flexibility. This wasn't available, but next slide, please. We've heard the feedback from the market. Over the past 24 months, there's been some important community milestones that DataStax has contributed to into the open source Cassandra. We've improved performance, operational reliability, and observability. Obviously, these were aspects that was not available, so we've contributed back. This is Stargate. Any of you have explored Stargate APIs? Awesome, cool. I'd like to talk to you, sir, about it in terms of your experience. So Stargate APIs, as an application developer, a lot of us were application developer apps. Now, the data analyst team comes and says, hey, this is a tangible use case for us to implement. You have 2 choices. You have a choice of accessing the data using a driver, or you have the choice of basically saying, I just include a simple functional API call and use it. It's almost a no-brainer where you want to go, right? So this target API, please don't underestimate the power that this creates in terms of us basically turning around the SDLC lifecycle and getting our products faster into the market. Please don't underestimate this. This is a huge value add that DataStax provides and Cassandra provides in general for the developers to sort of leverage data, right? Accessing real-time data through your applications without having to worry about drivers, maintaining drivers, versioning them, worrying about different drivers for different operating systems, taking all those things away is super important. That's where Stargate comes in. And lastly, Cassandra, right? One other buzzword that must be doing the rounds in your organizations is multi-cloud. You all agree, right? You don't want to be locked in to a specific vendor. You need an operational plane that allows you to implement a multi-cloud strategy. That's where Kubernetes comes in, right? And Cassandra that we've contributed back allows you to basically have a Kubernetes-based Apache Cassandra that you could choose to deploy on a cloud of your choice or onto your own local data centers, right? So these are some important contributions we've made onto Cassandra, and that sort of goes back to speak about the previous slide where we received market input in terms of what the so-called shortcomings were, right? So these are some changes going in. So this is about Cassandra. I'd like to slowly pivot towards talking about AstraDB. Next slide, please. Right, so before I do that, again, I spoke a little bit about this, but none of these should be any surprise for any of you, right? Because you've been working on data-based applications. You want to power innovation, you want to use data. That's there. I mean, we've seen customers like Verizon do that. You want it to be turnkey. You don't want it to be a complicated process for you to basically take it from this cloud provider to another cloud provider and implement a bunch of changes to make that happen. You want it to be turnkey, right? Your developers should be productive. You don't want your developers and your production engineers worried about maintaining different Java drivers and making difficult decisions around changing operating systems and so on and so forth. You want them to be productive. They have to be secure. I don't even have to elaborate on that. But I think none of this matters, right? A lot of you are key decision makers in your companies, right? None of these matters if the solution is not economical. So it has to come with the best unit economics, right? If that doesn't exist, then it doesn't make any sense at all. All of this may not matter that much. So it has to be the combination of all this that is basically at table stakes when each and every one of you are making decisions, either as a developer or as an operator or a decision maker within your company to sort of choose your database management system, right? So far, all of you agree with this? Cool. Thank you. Next slide, please. All right, so that's where, basically this stack comes in. Let me just pivot to, go to the left a little bit. I just want to talk about this, right? We spoke about this a little bit. You really want to have the flexibility of operating this anywhere, right? It could be the clouds. It could be, a virtualized solution on your own. It could be on your own data centers and so on and so forth, right? You want to do that. When it comes to data, you also want to have a persistence layer, right? And you want this persistence layer to be scalable, right? What are your choices? You could have file storage, you could have block storage, or you could have object storage, right? Some of us are developers out here, a lot of us are developers out here, right? Having an object storage persistent layer is super important for our applications leverage. It's just much better scalable. So this is, again, a key part of the data stack. The third is Kubernetes. Now, if you want something that runs anywhere, you need an operational plane that can be deployed anywhere and used anywhere. That's where Kubernetes comes in, right? So this is, if you notice, these are generic, but this is very specific, right? So Kubernetes helps with that. So once you have these bottom of the stack components in, then you have your database and streaming and stream processing come in, right? I mean, all of these three aspects are very important. Database is where you basically, your application stores and retrieves data for making decisions. Streaming is real-time access. And stream processing is something that you do because you want to understand what kind of data is being streamed. Think recommendations and engines and stuff like that. So all of these come into play, right? Which is as the next layer. But fundamentally, if I cannot access what I'm basically storing here, when I say I'm putting myself in the shoes of a developer. If I cannot access that through my applications easily, then all of these do not count too much. So you have to wind it up with a data API gateway layer. If any of these components are missing, you're not going to be in a position where you can execute a successful data strategy for your company. Would you agree? Right? And please let me know if you disagree, right? I mean, I'm genuinely seeking feedback, right? So this is something that we've basically seen. We've seen this play out again and again with multiple different customers of different shapes and sizes at different stages of their journey. And this is the stack that we believe can give you an optimal data strategy, a chance to implement an optimal data strategy, right? So that's where it is. Slide, please. Yeah, so again, speak about 3 different kinds of people: developers, APIs for developers, operators, Kubernetes. All you have to tell your operation SRE team, production engineering team is, get deep expertise on Kubernetes, and then you scale operations that way. And CIOs, the decision makers, right? You have to have a total cost of ownership savings, right? It doesn't matter if the stack exists, but you want to have a 3 to 5x TCO savings, right? Without compromising on performance, right? So that's what it is. And that's where Astra DB comes in. There's a link, and in fact, there's a demo that my friend and colleague Jonith is going to be giving in terms of how to access data in Astra DB, as soon as I finish this talk, right? There's a bunch of features around it, right? Around fast time to market. You want to have some interface that basically gets you to roll out a database service really quickly. Zero lock-in, you can deploy it on any cloud. At this point in time, AWS, Azure, or GCP. Elasticity and high availability. No operational overload. Again, I'll repeat this. No operational overload. We take care of all the operations. True consumption-based billing, right? I mean, when you're figuring out the costs of your database applications or your database setup, if it's a native setup, how are you even figuring it out? You're thinking about infrastructure, you're thinking about development time, you're thinking about deployment, you're thinking about operations. There's a lot of dynamics that comes into figuring out the costing itself. Wouldn't it be a lot more better if you were to take all these out of the equation and just worry about the reads and writes and storage? We give you 3 variables: reads, writes, storage. Just have these 3 entities and figure out your consumption costs. It's as simple as that. It simplifies your calculation of your costs and the decision that you make on that a lot as such, right? And obviously developer velocity, I think I've spoken about this enough using APIs and so on and so forth. But fundamentally, these are the features that Astra DB provides for us, right? Next slide, please. Okay, so it's a SaaS solution, right? A SaaS solution means it's going to come with multi-tenancy, right? Multi-tenancy means, some of you might, start getting a little concerned. Am I going to run into a noisy neighbor problem? How can I get sufficient isolation and privacy and so on and so forth if other applications are going to be deployed on my cluster? So we just want to call that out very, very, upfront, right? So we want to say that, yes, it's a multi-tenancy that we're going to be using in Astra DB, but we're using some really cool solutions to ensure that there is isolation, data isolation, and also basically allocation of work to each of these specific clusters as such, right? We use something called shuffle sharding for service assignment. Shuffle sharding is a cool algorithm. It would take a long time to go into the algorithm itself, but there is a specific, happy to share this offline, but there is a specific link where shuffle sharding algorithm is basically detailed in an AWS website. I think they were the ones who came up with it. Please have a look at it. If any of you are interested, please knock yourself out, or if you want to have a conversation with me later, I'm happy to elaborate on that, right? And scaling of services based on the tenant needs and so on and so forth, right? There's a serverless architecture white paper that I would encourage all of you to download and read it, right? Because these are aspects not just specifically about the Astra DB, but also general features that you have to think about when you're making database solutions, right? So we'll provide a link to this, and then please feel free to download the serverless architecture white paper and having a look. Next slide, please. So again, SaaS service, some alarm bells, right? One of the decisions that we make as an engineering team is, obviously we're selling this to you saying that you don't have to worry about operations, right? We are taking care of the operations for all of you. But it doesn't mean that we keep application developers or our customers completely in the dark. There is some set of information that makes sense to you, even if it's a subscribed managed service as such, right? And that's what we endeavor to provide as a part of our health and monitoring service. If you can click, please. So you would get basically access to the fundamental information that you need. And some of you have used Astra DB and played around with it, so you know this already. You basically get your database level information and the metadata that basically is associated with it, the number of requests, whether it's reads or writes, how much of storage you've consumed, because these are the three entities that basically, 3 or 4 entities. The other entity is obviously the amount of data transfer that's been done so far. You get that, in a quick view as such. Click please. And then you basically get some health dashboards. You get, dashboards about how your reads and writes, the volume of the reads and writes, then errors, latencies, and the size distributions, right? Sometimes you want to go back and then review your application saying that, hey, why am I making so many sizes that are greater than 1 MB or 4 MB or whatever that number is that concerns you. So you want to basically get that information, we provide that information, right? But the underlying principle of providing information when you're providing a SaaS service is provide the right level of information. Provide information that makes sense to people who consume the service, right? I mean, this could be any SaaS service. It doesn't have to be an enterprise database. Look at your Airtel bill. I'm pretty sure there's ton more metrics that the Airtel technical team looks into, but they expose stuff that's relevant to the consumer, right? And that's our endeavor also out here. You get a quick view in terms of reads and writes, storage. So anybody who's a decision maker can say, hey, it looks like my writes went up. Not this number, but my writes went up. Why? What's happening, right? It looks like my data transfer is increasing. So you can make both technical and business decisions based on this. And when you run into issues, you basically can do a fair level of analysis and troubleshooting before you can report a problem to support, DataStax support, or solve the problem yourself, right? So this is something that we wanted to call out specifically. Next slide, please. Backup and restore. For how many of you is this a pain point? Backing up and restore. Expensive. Awesome, right? So this would resonate to all of you, right? So this is a pretty busy slide. I want to focus your attention on this horizontal thing first, right? So we take continuous hourly backup, and we have the ability to give you snapshots. Now let's assume something went wrong, and you want to basically take a particular snapshot. We store this for 20 days, by the way, right? All you have to do is lodge a ticket, and there's a support life cycle that essentially kicks off immediately once you lodge a ticket, and then we'll be able to notify you once the data restore has happened, right? It's as simple as that, right? So again, activities that in the previous world used to cost money, take a lot of time, take away efforts towards something more tangible for the business, is something that you can basically have DataStax worry about and take away that pain point from you, right? Next slide, please. Okay, few more slides, and then I'll stop. We'll go to the demo. I realize I've been speaking a lot and inundating you with a lot of information, but I hope it's made sense. Flexibility, right? APIs, there's multiple different ways to access data. We spoke about drivers, but there's different kinds of API interfaces also, right? You've got JSON at one end, and you've basically got GraphQL at the other end, right? And throughout these interfaces, you're accessing different kinds of data models, right? It could be column family-based data models, documents, graph data models if you're building a social media website where there's relationships and stuff like that. So you have multiple data models. You cannot say that my application will be locked in only to a certain kind of data model, because you don't know what application you're going to be developing later in future, right? So you have to have the ability and flexibility to be able to support different data models. By extension, you need to have different APIs and drivers supported. If you want this, you need this, right? So this has to be provided. Plus, what I spoke to out here, which is managing your DBaaS service, right? Database as a service system. You obviously want zero downtime, operations, auto-scaling, and so on and so forth. So the combination of this, which is basically a flexibility and the management stuff, is what AstraDB provides. We provide support for all those APIs and drivers, and also support for the different multiple data models that you're going to be using as a part of your application, right? Yeah. So just a little bit on drivers and APIs. The important thing, again, very busy slide, but the important thing to note out here is that as you move from the left to the right, you're basically moving from structured to a little bit of unstructured, semi-structured, right? You're moving from uncertainty to rapid prototyping, right? But you want all this, right? Assume a world where you just had drivers and REST API. If you have a proof of concept, what will you do? Your proof of concept is going to take a lot of time. You want something to start up very quick. Start up something with a simple JSON payload, roll it out, prove the proof of concept, and then go into actual production development. You need to have this extension of interfaces, API interfaces that are supported, right? So it's something that is important for all of us to consider as we actually evolve, understand our data, and evolve more applications out of it. Next slide, please. I'll leave the talk with this particular slide, but again, available throughout the day. Any questions, please feel free to reach out to me. GigaOM independence study, right? Total cost of ownership, about 75%, 3 years total cost of ownership. 95% less staffing cost. Again, please don't look at, there's a certain negative connotation to staffing costs. Please don't look at it that way. What this means is actually reallocation of our talent pool to something that's more relevant for the business, right? So you get that flexibility back to leverage the talent pool better. And then lower infrastructure costs, right? This is an independent study in terms of what is the kind of value add that Astra DB can provide to you, right? And a simple comparison, right, which basically gave you that 75% number, about $3 million with self-managed Apache Cassandra, right? And when you moved on to serverless Cassandra, that's what the cost was, right? Right, so hopefully that gave you a gist in terms of what the thought process is when you're basically designing, making data strategies and designing data applications, and why Astra DB may be a good fit. I would really request all of you, one last request before I go and hand it over to Javneet, is that if you've not tried Astra DB, please register today, right? Please register, play out with it, and then give us feedback. We really look forward to it. Thank you so much for your time.
All right, we have Mr. Jonathan Singh here. He's going to show us the Access Data demo. Ladies and gentlemen, give him a good boost with a huge round of applause.
Hello, everyone. So, as I started my career as a DBA, I always worried to set up big clusters because I started as a DBA of distributed systems where I play with HBase, Cassandra, MongoDB, and many other databases. And what was the most challenging task was those adding the nodes, removing the nodes, then stabilizing the clusters and all those kind of stuff. And whenever you keep on mostly working on open source technologies and all those kind of stuff, you have to manage a lot of files, configuration files. Like in Cassandra, we have to manage cassandra.pyml and all different kind of files. So with an Astra, this pain has a lot more reduced. With a click of a button now, we will deploy the multi-node Cassandra cluster from here. And that too as a serverless. I'll quickly, so all of you can quickly, whenever you have a time, you can sign up at astra.datastack.com. This sign up page, you can simply sign up with your either in official work email ID, or you can sign up with Google, or most of developers already have their GitHub accounts. They can quickly use a GitHub to sign up. So here I'm going to sign up with my official Google account. So quickly, after signing up here, we will be logging into an Astra DB web UI. We also can use Terraform APIs to do the deployment, but as an ease demo, I can show you using this web UI interface. So if you see this web API, you see two different, what I can say, the parts. So in the first demo, I'm covering only database as a service part, where I will give you a small demo how you can deploy a database and how can you access the data using the API layer quickly from an Astra. So if I talk about creating a database, it's very simple. You can simply click on a create database button, and you can simply type whatever database name you want to give. For example, I just want to give today an Astra day, and I just want to give him demo 01. And then I can choose whatever cloud provider I want to deploy. So with a click of a button. So for example, if I want to get it deployed in any of the GCP regions, I can do that. And if I want to deploy it in AWS, I can quickly do. For example, now I'm going to deploy it in AWS Mumbai region, so I can simply select that. And as I also want to tell that every user who will sign up for this will get $25 free credits every month. So if you want to start with a small testing, and these $25 credits are sufficient to store almost 60 to 80 GB of data and do few million read and writes per month. So with this create button now, the database will quickly come. So you see that database is created. That means what your database means, means your Cassandra cluster is ready now to get accessed. It can be on a shared TNet or it can be on a dedicated TNet. It depends upon the workload. We always work with our customers to discuss what kind of a workload they are running and what kind of a performance they need. Based on that, we will select the workload for the customer. So with a click of button now, we are able to deploy a database. And you see here the database Astra Day is getting created, it's initializing. It may take few seconds to get initialized. Within 1 minute it will be initialized, but I want to utilize the time and I'll show you through the other database how different things we can access. So as Venkat was showing, it's very easy to monitor your usage here because we charge on these three metrics, and these three metrics are available on the screen. The detailed metrics are also available in the billing, but on the screen you can see how many read, write requests or storage is consumed as of now. And you can also add a region if you want to your database to be a multi-region. You can simply add a region and can choose the different region where you want to spread your database or where you want to scale your database to a different region also. And then we have the health tab. So health tab will, now the Grafana dashboard will load up, which will show you how many read and write requests you have consumed or done. And apart from that, it will also talk about the latencies, because we feel that what matter customer most is the latencies. They want always to be in certain threshold of a latencies, and that is what this particular dashboard covers for them. Apart from that, you can also export some additional metrics, but these are some important metrics which you always need and always want your application to check that how much latencies you are getting and all those kind of things. This is one of the most important, what I can say, that page which I feel when I started working on Astra, because it gives you a complete visibility how you can connect to a database. So for example, we're talking about a Stargate API. Now if we want to make an API request to a database, you can get all your details here. Just you need to generate your token. Whatever token you need, token can be generated. I can show you how you can quickly generate your token. So this token can be generated, and then you can start reading and writing your data to the database. We also support the traditional drivers and all the steps, for every particular language, the detailed steps are given down. You can simply use these steps to connect to the database. You don't need to look for any other documentation. Very simple and straight connectivity steps and driver download options are given out here only. And you can also choose some of the cloud native like Go, Rust from here to access the database. We also support SDKs, different kind of an SDKs like JavaScript, Python, and Java SDK to connect to the database. Apart from that, so for example, a lot of customers, what they do, a lot of people I see, they do a lot of bulk ingestion on Cassandra using some of the tools like Spark or any other tool. So we already have the Spark connector, and many more connectors are also available there, which I would like to show you. Just give me a second. So we have a new UI in the beta phase. I just quickly want to take you through that also, because it shows a lot of integrations which we support for our databases. We support, you can connect to the Lambda functions, Apache Airflow. You can have a lot of connectivity options here, which you can choose and connect your database directly from here. So all those are tested and used connectivity methods which are available there. Apart from that, we also have a lot of third party which is available there that also can be supported. I'll continue my discussion with the databases. So this was the traditional connectivity page. Then we have a SQL console. And this SQL console gives you the flexibility of writing the traditional Cassandra query language queries from here. You can also have your own SQL as such installed on your laptop, and you can connect to this Astra DB remotely hosted. But you can also run your traditional queries like listing of the key spaces or something from here also. So, and the last few things, so we have a CDC also here. So if you want to capture any changes, capture the changes from any of these tables, and you want to send to the downstream target. For example, a lot of us make now, we try to make a data lake in the object storage. And we want, at the end of the day, the data moves to the data lake storage, and then we can use Presto or some other kind of a technology to query over data. So you can simply enable the CDC on the table and send that data to the downstream targets like Snowflake, object storage, or any other database of your choice, which you can do. And the final, you can, this is a setting page which helps you to cover the private endpoints and all other kind of activities for your database. For example, if you want to export the metrics, for example, I'm exporting all the metrics to CloudWatch and getting the alerts from the CloudWatch if and my latency threshold is not matching and all those kind of stuff I can do from there. Now quickly a data access demo. So I'm using this Postman as a tool because all of you might be aware how to do a SQL query to the database, but I want to show how we can do it with a JSON document. So simply I've configured this, what I can say that this as a Postman, and I'm simply sending the HTTP request to the database to list all the collections in my database. So when we talk about collection, most of us think only about MongoDB or any document DB as a database. But in Cassandra, in Astra, you can also store the collections. You can store the group of documents as you store in other document store databases. So this is, so it quickly came up with a list that I have 2 collections available in my database. Same, if I want to create a collection, quickly I can go. I can simply name my collection whatever I want. And for example, I named it 2, and simply I can send this query, this API request to the database, and 1 means it's successful. That means my database is, collection is created, and I can go and list it, and now I will be able to see the 3rd collection, which is new collection 2 has came up. What? As of now, these are all default headers of the Postman. I have not added any header as of now. Okay, so it's all default headers of an which the Postman came with a Postman which came up. So if required, I can share with you all the details how you can connect using a Postman or Swagger. Yeah, token I have passed here. I'll just show you. If you see this I have configured as an thing. In the variables, I have passed these variables like Astra DB ID, a region, and the key space to which I want to connect. And also for an authorization, I passed a token here, Cassandra token, to which I want to connect. So this is an authorization token which I have sent to the for the communication with the database. And now, even if I want to insert a document, for example, I want to insert this in new collection 2, for example, the new document, some stuff, I can go and quickly insert it using this document ID. It gives me whatever the default document ID it has taken, and the result will be given back, and I can list those documents quickly from here also. So this is a listing of the documents. So this is a simple way how you can access your data using an API. I not choose here to way of traditional Cassandra query language to show you how we access the data, because all of us are familiar how we can run those queries. But this is how you can access quickly an API using the API calls. Okay. So if you have any questions about Stargate API, how you can access the data, I am available here. I am happy to help you and support you there. Thank you.
Thank you so much, Mr. Jonat Singh. And ladies and gentlemen, once again, let's put a huge round of applause for Mr. Lakshmi Venkat, for giving a very informative presentation. I request Mr. Hendel to please come up on the stage for the wonderful announcement now.
We always and we love enterprises, right? So we go to the places where you all are. So ladies and gentlemen, put your hands together for Suresh. Now, Suresh, can you just stand up? Can you? So this is a brief about him. He has submitted 3 top priority hackathons. He has been an awesome student and one of the committers. You want to say a line about this, or how was your experience?
So this was my first international hackathon, by the way, and I'm Suraj Vijayan from Chennai. I'm currently in my third year pursuing computer science. So when I first saw Cassandra, I heard Cassandra was completely off from the other traditional databases. Even though it's a NoSQL database, it looked like the queries look like SQL queries, and so I was wondering, would I be able to participate and win in this hackathon? Yeah, I really won this hackathon because the full credits goes to the DataStax developers advocacy team, because they did clear my doubts every single time when I asked them. They were never like going away from the doubt. You should probably go about implementing other solutions. That's what happens in some of the hackathons, but in this hackathon it was not like that. And we did had many workshops. That's really impressing. And also you must check out the connection tab of the Astra DB user interface. It's pretty self-explanatory. Even a little kid can work and play with AstraDB to create data and play with it. So I'm someone who loves data, like the way it's being brought into your application through the users, and how it's stored, and how it's like analyzed and given back to the user. I really love the process, but I don't get into the data, obviously, but I really love that process. So what I thought was that, let me just, what to say, why not take this myth out of the people that Cassandra is so complicated. So why not build a no-code environment? So someone who doesn't even know how to code, or someone who's moving from SQL to NoSQL, let's say he's ended up his first NoSQL is Cassandra. So they can choose, use this UI. So it's pretty self-explanatory. You just paste your app token, and you create tables and you create nodes in single clicks, basically single clicks, and not even single line of code to do so. When inserting data, you obviously need to write codes. So yeah, that's an exception. Yes, so you can also like create a node. Every single feature what the AstraDB user interface provides you. So this is something like everyone can check out. Like you just need to create a database. Let's say you are a startup founder, you didn't know how to code it. It was your developer who took care of this, but in some time you want to see the data, what is inside of it. So you can ask your developer, hey, can you give me the AstraDB token? And you can just paste it, and the UI is pretty self-explanatory. So you can get into the table you want, and you can just search for the data, and that's it. So you need not learn how to code. So that was the main aim to build this project, and yeah, it won the hackathon. So that's it.
Thank you. Thank you so much. Yeah. So this is very unique that I have seen with DataStax also, right? That when we would have seen a lot of huge enterprises coming and speaking, but we love the young, energetic, ignited, awesome youth of India. Thank you so much for being here today. Round of applause. We have another gentleman, Mr. Gowda here. You can just stand. So he actually was using open source, and then he has moved to our managed Cassandra, and now he uses Astra. So he'll just introduce himself and just tell a couple of sentences about his experience. Guys, is this helping you? Thank you.
Yeah. Thank you, sir. So my name is Rakesh Kumar Gowda. I am a data engineer at EY, and I have 7 years of experience in Cassandra DB. So when I started my journey, I was in RDBMS. Then within 6 months, I moved to NoSQL Cassandra. So from the beginning, I'm using DataStax enterprise version of Cassandra. So there we were considered to the open source. There we were seeing some improvements, but still we have to manage those maintenance and operation kind of things with DSE. So like those repairs, it sometimes if the volume is large or data is more, so the repairs it keeps on going for few days to weeks. And similarly, if during busy seasons, if we see some data load increases or user increases in that application, so that time scaling up that requires like adding more nodes, the those things it require like few days to weeks. So what we did, we just heard about Astra, which is a software as a service or a database as a service. So we tried out for 6 months, and we checked all those bigger projects which was failing or which was taking more time in DAC, and we ran those projects in our in this Astra environment. So and we see the performance gain there, and the projects were completing faster, and there was very less issues compared to DAC. So after 6 months POC, we now almost 8 to 9 months we are working on Astra, and we see a good improvement there. And in the billing wise also, there is a billing dashboard in Astra UI where we can go and check what is the consumption till date or monthly wise. So that also we can see. So in that perspective also, so we are gaining like more from DSC. So the cost is lesser than DSC. So in altogether, yeah, Astra is like proving out to be a showstopper. Yeah, thank you.
Thank you, Rakesh bhai. Thank you so much, guys. And with this, hand over back to you.
Thank you. Thank you so much, Mr. Henry. For the second session, to explain about real-time data pipelines with the Astra streaming, there's a wonderful gentleman out here. They are none other than Mr. Chirag Shah, data architect. Please welcome him on the stage with a huge round of applause. And also Mr. Jonit Singh, data architect. Over to you guys.
Hello. Hello. Audible? Okay. Good afternoon, everyone. I think Jimmy we call him Jimmy. Johnny did a great job of giving a quick demo of what Astra DB is all about. Would you like to know more about it? Yeah? So I think I'm standing in between that. So bear with me for some time, 15, 20 minutes. I'll set the context. He has gone through what database as a service that we provide on any cloud. I'm going to set the context for streaming. So you will be able to see live data streaming and how we do that. Streaming generally is a complex topic because you have to take the data from source, you have to process it somewhere, you have to ingest it somewhere, and then basically get the output that you are expecting, what the business is expecting. And all this thing is happening in real time, near real time. That means it has to happen probably in few milliseconds or max in few seconds, right? So that's a complex problem to solve. And what we have realized is a lot of customers today, while they have implemented some kind of a messaging queue or real-time processing engines, they're struggling when it actually starts scaling beyond a certain point, right? Just to give you an example, if you have seen some of the downtimes on some of the huge applications that you have in public domain, most of the downtimes you'll find is because the real-time processing engine is broken somewhere, right? So we have basically taken that challenge and the problem statement of simplifying the messaging queue, streaming platforms, change data capture, and putting it into as a service, right? So you don't have to worry about deploying this, scaling this, managing it. It's completely driven by our backend team, and you don't have to worry about the overall operations of the various component that goes into managing a streaming platform or a change data capture platform. Does that make sense? So let's dive deep into it. I want a show of hand here. How many of team members here are DevOps practitioners today in the room? Any DevOps practitioners? Any data architects who are actually managing data? Okay, good. So I have a good sense of audience that I have. So I'll tame my conversation accordingly. So let's look at some of the key trends that are going on in the market, right? I think these are the buzzwords that we all keep hearing about, right? Digital experience is changing the way we live, the way we drive our business, and the way we interact with people, right? Whether you want to book a car, whether you want to book a hotel, no longer you go and do any offline transaction. So digital is real, and it's become more and more real even after the COVID and the pandemic situation. Today you get hospital services or consulting services, doctor services all online. Video conferencing is happening, right? So digital is real. I don't think there is any doubt about that. Education is becoming online. There's so many universities and academy which are running online today. The second piece is once you have all this data and you create this digital experiences, there's a lot of data which get generated. What do you do about that data? It's basically all about AI ML, right? Just to give you an example, Netflix using Cassandra processes billions of requests every second for your recommendation. So if you open up, every one of us, if opens up a Netflix app in this room, every one of us will get a different recommendation for a movie or for a series or what language that you see. Not only that, if you see and observe it correctly, the movie banner that you see is also customized. So if you take any movie, right? Let's say Bahubali, I may see something else as a banner, you may see as something else as a banner. The banners are also customized. And how does that happen? The whole AI ML engine that is running behind, the logic that is running behind, based on your age group, based on your demographic, based on what kind of movies that you have seen earlier, what kind of series that you like, what kind of likes and dislikes that you have hit. All this gets correlated and gets into an AI ML model based on which you get the recommendation of the movie. Not only that, you get the banner that you see. Sometimes you'll see a female banner if it's a young age guy, and you will see a Bahubali banner if you have probably a person like me who is old age, right? So, so that's the power of AI ML that you can start looking at when you have data. Just having data is not going to help you, but making sense, making meaning out of that data is going to be very powerful. Edge computing, again, with the advent of 5G, edge computing is becoming very, very relevant. We are talking to some of the telco customers where they need solutions at the edge. When I say at the edge, I'll just give you an example. Imagine that you can, how many of us play a video game at home? Xbox, PS4, yeah? Very few? I'm surprised. I at least play, let me be honest. So I enjoy playing those games, specifically during weekends with my kids. Think about it, if you can get gaming as a service from your telco service provider. That's going to be the future. In the next 6 months, when 5G becomes real, you will no longer buy a PS4 box or an Xbox. You will basically stream that game and you will be able to play it online. Right? That's a very simple example that I gave you. There are endless possibility when 5G gets launched because it's going to be ultra low latency. It's not low latency. It's ultra low latency of applications that will get installed on your mobile devices and computers. What it really means is gaming is one part of it. There would be serious businesses that would be happening on edge computing. Why is it possible that I can play game online on 5G? It's because a near site somewhere, the tower that you see, the telecom tower, that's where the whole processing is going to happen. That's the edge device that's the telco service provider will deploy. Think about it, a telco service provider is deploying an PS4 for 100 people in that area. And 100 people are playing it based on the number of times. If you have played it for 5 minutes, you will get charged for only 5 minutes. So you don't have to buy a big PS4 or an Xbox. This is a possibility in future, and that endless possibilities. Hospital, Maybe there is times when doctor will be sitting at home and do surgery in an hospital, right? Based on the low latency applications that we are getting. So these are some of the use cases we believe Cassandra is well suited for. And on the real-time basis, you will be able to take some of the decisions. Now this is a snapshot of last 30, 40 years what's happened in the industry, right? If you look at it, it all started with client-server architecture. It all started with mainframes. It all started with where you had to install thick clients and you had to install something on your computer for you to connect with then server, right? You had a software which would get connected. Think about it, no longer we install MS Office in your computer, right? Because it's all on the web browser, right? So there's nothing that you get installed. So that's the era of monolithic. Then the era came of specialized domain softwares. Specialized domain software were ERP softwares, right? Where you had a domain-specific application like SAP or Oracle or business analytics or anything that would be very, very specialized to a specific domain. What has happened now today in the cloud world, it's all microservices-based architecture. Let me give you a simple example. 15 minutes back when I was checking my bank account, I was able to see the balance, I was able to download the statement, but I was not able to basically look at all the money transfer that I could do. So I was not able to see the pay list. What does that mean for you on the microservices based? There's something wrong in a microservices of fund transfer, but all other microservices are running perfectly fine. Compare this with the traditional way of doing things. If something goes wrong in my application, the whole application goes down. Do you agree with me? So microservices-based architecture basically provides you customization of what, it's basically kind of an isolation of your services. Fund transfer is a service, right? Balance check is a service, right? If you want to do an UPI transaction, it's a completely different service. If a UPI service goes down, it doesn't mean my whole application goes down or I cannot see my statement. They are completely isolated services. That's the power of microservices, right? Does that make sense? Okay. So let's look at what real-time analytics needs in today's world, right? Very simple, there is a producer and there is a consumer. How many of you know Kafka here? Yeah, so you all are, I think 60–70% of people understand this slide. I'm not going to spend too much of time on this, but it is important to understand that we are connecting the legacies to the microservices. Think about this as a CBS, your core banking application, which is producing transactions. When you do a transaction, it goes into a core banking application, right? But it can't do a real-time analytics, or it can't give you a real-time meaning out of it. So you basically put a messaging platform where it extracts the data from your core banking legacy and puts into a consumer which can actually process the real time, right? There are key 3 things that needs to happen. One is producer, second is broker, and the third is consumer. What does this whole architecture do? It basically does messaging, streaming, and stream processing. I'm going to talk to you about how we are able to simplify this whole process for you, right? People who have implemented Kafka, they know that at initial level it works perfectly fine, but as you start scaling, as you start processing millions of records in Kafka, it basically needs scaling up. Scaling up means it needs additional nodes. What it means is additional cost, additional storage, and additional persistent layer that you need, right? And to help you to scale this beyond a certain limit is where we come in. To simplify the whole architecture so that you don't have to keep managing all the nodes of clusters that you have, we basically build as a service model here. Let me skip this slide. So we basically built this whole framework using an open source technology called Apache Pulsar. So you heard in the first session about Apache Cassandra. Now you're going to hear about how we take that data which is persisted, which can be moved out on a real-time basis onto various platforms, right? So that's the change data capture. The second part of it, you want to ingest the data in Cassandra from various sources, right? So we will allow you to ingest data on real-time basis into Cassandra and take it out onto a third-party system downstream applications, for example, right? So what Apache Pulsar allows you to do is, it's obviously open source. It guarantees you message delivery. Again, this is very unique to what other messaging platform does. It guarantees you the messaging delivery, otherwise it will keep retrying and it will give you a failure message, which is very unique. The second thing it does is it also maintains the sequence of the events that are happened. At some of the application, it is important for you to maintain the first message that has come, the second message, and the third message. The sequence is very important. For example, a time series data. How many of you working on time series data here? Right, a lot of people, right? So time series data, it is important that you maintain the sequence when the data has come in, and you don't want the data which is latest to come first and the old data sitting there, right? So the architecture actually helps you to do sequencing of your data properly. It also allows you to do a tiered storage. What it means is your processing engine is separate and your storage is separate. That means if you need more processing, you can just add more CPU and memory. And if you need more storage, you can just scale your storage. So it's very decoupled architecture that you have. It is a very distributed architecture. Again, a unique value proposition that Pulsar brings in, where you can have your producer, broker, and consumer sitting in different locations, different data centers, right? So it's a distributed architecture with one single instance of your messaging platform running. Any questions? I would love to take questions rather than doing a monologue. So let's move on. Astra streaming, as I was saying, so you saw Astra DB. We bring in Astra streaming, which gives you no operations out of the box. You can deploy it in multi-cloud. Jimmy is going to show you how this happens in action. So hold on to this slide so you can see it in action actually happening, right? So Pulsar as a service, it basically is a seamless, modernized, out-of-the-box messaging platform like Kafka. As I said, it's a very distributed architecture. You can basically bring in different types of data from various sources into Cassandra, and you can take that out from Cassandra. So you saw CDC console. When Jimmy was processing, you saw CDC. So basically what it does is, anything that is ingested in Cassandra, you can on real-time basis throw it out to other applications. Let's say, for example, you want to do some reporting. Let's say you want to build analytics dashboard on real-time basis. Think about a weather application. And if weather keeps changing every few seconds, and you want to keep updating that. Or let's say a cricket match is going on, and every ball the score changes. On real-time basis, you want to update the scoreboard, right? Those kind of applications, you will use CDC. It stores it and immediately updates your portal. You store it and updates your portal. So it, on real-time basis, it keeps updating it, right? No operations, as I said. You don't have to deploy your broker, consumer, or you just have to deploy the drivers on your producer side, and it will take care of everything else, right? You just have to point Cassandra, where is your source application, and everything else is taken care of. Jimmy will walk you through that. Very important is zero lock-in. That means you can deploy the solution on-prem if required, or you can deploy it on any cloud, which you have already seen the console, right? You can deploy it either on AWS or GCP or Microsoft Azure. So basically, you don't get locked into a specific hyperscaler services, right? That's very unique that we provide. And this is one of the key reasons where a lot of customers look at us, because they don't want to just get locked into, they are okay to buy infrastructure from hyperscalers. But when they buy services on top of it, they basically get locked into those services, right? It's very difficult then to get out of those services. So that's where a lot of customers use us. Obviously, you can start with free tier, which Jimmy spoke about, $25 every month that will get refreshed. The other thing that gets added is basically Pulsar functions. Jimmy is again going to show you the console, how pulsar function works. What pulsar function allows you to do is not only stream data, but it can also transform your data. What I mean is, if you are, let's say, taking a row which is getting processed on real time and persisting on Cassandra, out of that row, if you have 10 columns, but for processing that data, you only need 5 columns out of it, right? Let's say if you have username, Aadhaar ID, and address, you don't need address. You want to just trim that address column, then you can do it using uh, pulsar functions. It also allows you to add something or remove something or enrich. So basically, if you want to enrich your data before you process it, on the real-time basis, on the fly, it's all happening on the pulsar function. Does that make sense? Any questions? Okay, great. So this is what the change data capture, which Jimmy already spoke about, where you can take the data out from Astra DB, push it to streaming, and send it out to any third-party application. Or you can basically take the data from third-party application. Think about it, if you have a Kafka message, and you want to push it onto Cassandra, or you want to push it onto Pulsar, or you want to do some functions, that means you want to transform some data. All that is possible using this Astra streaming process that we are running, okay? Any questions before I hand it over to Jimmy? I think you will see some real time, yeah.
Yeah, so my question is the streaming part.
Yeah.
So can we do graph queries on that? Because
Absolutely.
some real-time investigation, something like that.
So I think just for everybody's benefit, the question is, can we do graph on the database? So Jimmy spoke about the API layer. In fact, the API layer supports GraphQL.
Okay.
So you can basically have, when I say GraphQL, if you have multiple instance of data and you want to do joins and edges and vectors so that you have a meaningful outcome from various instances without doing internal joins and creating additional database. Absolutely, graph is one of the key considerations. So we do graph, we do gRPC apart from REST API that we have. Okay? Yeah.
Yeah, because yes, it can. Yes, yes, yes. So it is able to do that.
Because what I think is Akai supports this. I'm not sure whether Pulsar.
Yeah, so basically it has a persistent layer in between.
It's not. What I'm I'm not even talking about the persistency. I'm talking about the input is the data. Input data
Is very fast.
Your consumption speed is very slow.
So the reason you will not have this issue in Cassandra predominantly.
It's a streaming. You are not even come to the Cassandra.
Yeah.
I'm in Pulsar.
Yeah.
Okay, I'm pushing the data like anything.
Yeah.
Whereas as a consumer, as a Cassandra,
Yeah.
it has to consume that much.
Correct.
But that for some reason it is slow.
So I'll tell you. Yeah.
Black pressure builds.
Yeah. I'll tell you a classic example. There is a customer out here in Bangalore who pushes 1 million records per second. It comes from across the globe from the IoT devices, right? And they're today streaming using Kafka, and they want to basically, they're using Kinesis today. And Kinesis is becoming a bottleneck, right? And it's actually building a back pressure, what you exactly said. And they basically started using Pulsar, and they've realized that Pulsar and Cassandra, because Cassandra also can accept so much of pressure. The inherent architecture of Cassandra, we're not going to get into the depth of the architecture, but then the way Cassandra is architected, I give you example of Netflix. Why are they able to process billions of records in a second across the globe? Is because Cassandra inherent architecture is to handle billions of records, store it, process it in sub-millisecond of latency. And if the back pressure is building, if what you're saying, we definitely have solutions to architect it in such a way that we can handle that back pressure. So we can definitely, yeah. Yeah. And because of the scalability aspect of Pulsar, you can actually and the distributed architecture. Like today, one of the challenge with some of the messaging platform is they are not distributed. That means one instance runs at one location, right? If you create another instance, it's a completely different topic and different consumer. We can have a single topic which is spread across multiple locations. That will take care of your back pressure. And it's all about how you architect it correctly. Right?
Sir,
Thank you so much.
I have a question.
Sorry.
Uh,
Yeah. There are publicly available blogs I'll definitely share. Meet us at the lobby and I'll take your email ID. I'll share it with you. Sorry, can you repeat your question?
That we have. Yeah. So basically, the offset management, like typically in Kafka, we have the the sort of a log management that where it actually stores all those informations, right? The data. So as compared to what do we have? Like what is the sort of storage structure? How do we store the internal messages?
I think we can talk about it on offline during the lunch because it would be a too technical conversation, right?
Sure.
So let's dig deeper into it.
Sure.
We'll talk about it.
Sir, I have a question.
Yeah.
When there is a Kerberos authentication is there, that time how this Astra is working in streaming?
Sorry, I can't hear you.
Kerberos authentication.
Mm-hmm.
When there is a Kerberos authentication, this mean at the time of data transfer,
Yeah.
when there is a Kerberos authentication is there, then that time how streaming is decoupled.
So there are different ways how we can authenticate. We use, you can also integrate this with LDAP if you're using LDAP. We have tokenized way of authenticating, and we also can do various token sharing mechanisms. If you have any other HTTPS protocol or a certificate that you want to connect us with, so there are different mechanisms in which, depending upon whether you're using driver, whether you're using API or SDKs, we can come out with a solution which will be definitely secure in nature. Yeah, we can go into the depth of it based on your requirement.
Yeah, hi. So can you please elaborate on the sequencing part? Like in Kafka, what we see, the sequences are based on the top. I mean, if it is on a particular partition, then only that sequencing can be maintained, right?
Yeah.
The ordering can be maintained. So how is it different from Kafka?
So
Pulsar?
what we do is Pulsar basically does something called as hashing, right? And it maintains the hashing algorithm for each message that has come in, and it maintains the time series across the cluster. And based on that, it will, if you define it that way, it will process only data which has come in first, will push it and hold on to other data. Obviously, it needs an architecture level because then you will need more persistent, because some of the data will get held up if the first data is not gone. Right?
So when you're saying held up, it is held up in the cluster
the
level
queue.
only? I mean, in the queue itself?
In the queue, and it's persisted at the cluster level, if you want to persist it. Or otherwise, it's always in the queue.
Thanks, makes sense.
Okay, I think we can take more questions. I'm around offline. If you have more questions, we can definitely take it. Exciting part, over to Jimmy, Jonit, to walk you through what I just spoke about, right? Thank you.
Hello. Hi. So thank you, Chirag, for giving the what I can say that all the information which I need to cover in the demo. So this is a quick demo which I will show. So I want to be practical a little bit more in this demo than the previous demo where I show you how you can use our own portal. Here, through this demo, I tried to solve one use case problem. So the use case problem is that, for example, if you roam around the city, and if I'm a store, and if I need to set some advertisements or some notifications to you whenever you are nearer to my store, For example, if I reach near the MACD, is they can offer some offer to me, like today you have price free for a burger. So this kind of a demo quickly I made using the Astra DB and Astra streaming as a combination. So if you see this demo, we have first part is a mobile app, which will be user app. Here I will just simulate the data using dummy, my laptop and location coordinates. And then you have a topic, streaming topic to which directly the data sends. So the data will go to the, actually we use the web logic to capture the web port to capture all the user location and information and then send to the topic user data. And if you see here, we are sending this data to the two places. One is the Elasticsearch, from where you can search this user, where it is available, and what are the nearest stores to that user. And for the persistent, longer persistent, we are sending the data to the STRDB as a storage there. And on top, number 3, you are seeing is a value proximity. So value proximity is a pulsar function. It's a serverless function which whenever the data comes, this function runs and this function calculates which is the nearest store available from that particular coordinate point. So if I am located at particular point called right now this coordinate, so what are the nearest restaurant near my particular coordinate point? And this particular then pushes the message to the topic push message, and then it will send to the notification store. And if I'm a user, and if I'm a store, if I have to search my user, I can search that user using an Elasticsearch or a regular based application where my users are currently and what are the users which are looking into me. So this is the what I can say that top level architecture of this particular demo. So this will be the data pattern which will be ingested. So we have a timestamp, an entity ID, and we have the longitude and latitude and IP, and we are also capturing the what particular mobile a particular user is using through this particular points. Okay, and this is something which we will calculate using the venue proximity. That if green is the user where it is there, and all the red marks are the stores which are near to that particular user where he can go. So quickly coming to the Astra streaming. So if I talk about this demo, I need multiple things. First, I need one topic to be created in the streaming, and then I need to create one function, and then I need to create sync and multiple syncs and all those kind of things. So if I quickly now go to the, because it's logged out. So if you see this is a streaming, so I need to create a topic. So for a streaming engine, we don't need to deploy a lot of what I can say that brokers and then need to install the Pulsar there. So with a single click of a button, I can quickly go and create a stream. I can give a TNet name and I can choose a region where I want to deploy this TNet. For example, if I'm giving some TNet name as in sample or demo TNet, and then I can choose the cloud region or whatever region I want to deploy it. I can quickly choose, and then I can simply go and create this TNet as a streaming TNet. Once this TNet is getting created, now you can see this demo TNet is coming down here. And if you see this demo TNet has a lot of what I can say that ways given here. Just like the StarDB, you also have the connect. If you want to write a producer or consumer using a Java, Python, Golang, so all those kind of an sample code and sample what I can say that steps are given here. How you can write how you can install the dependency for the Go language, how can you deploy the producers, okay? So, and how you can choose a consumer if you want a CDC consumer. So for example, you want to consume the messages, how you can do it. And same way you have a CDC consumer also, how you can write a CDC consumer. And reader is also given out here. So this is all the steps which is given to connect to a particular, what I can say, that streaming engine, whichever you have deployed. And then we have the namespaces and topics. It is similar to, as most of you are familiar with Kafka, in Kafka we also have the topics And then inside these topics, we have the partitions. So for example, if I take about this default topic, I can quickly add the, what I can say that any particular topic, like for example, data topic. And then this topic can be a persistent or non-persistent based on your choice. If you want that every message in this topic should be persisted, then you can click the data to be persisted. Or otherwise, you can choose it to be non-persistent. And then you can also define how many number of partitions you want for your data when it is getting written across the brokers. So with this, you can see the single click of button, you can go and click the, what I can say that you can simply deploy a topic. Then we have the sources. We support amount of sources by default. So you can simply click create source and you can choose a source type. For example, I want to send my data, from where the data is coming. So you can choose any of these sources and you can define, for example, if you want that Kafka should be a source for your data, or you want your data should come from the PostgreSQL or some other server. So all those options are given out here. And then the right is the functions. So functions quickly, you can write down any function. I'll demonstrate now a value proximity function in few minutes, which will calculate the proximity of a particular user. So these are the functions where you can quickly write down the function. You can do a lot of transformations with the data. So when I talk to a lot of customers, whenever they send a data to downstream target, they always use an ETL tools, like they have to use Informatica or some other tools to do the cleaning of data, or want to remove the unwanted columns, or they want to do masking of some data when they send to the downstream target for the reporting purposes, because those reports need to be generated and shared outside. During that period of a time, instead of using a third-party tool, you can simply do all those transformation of the data from here also. So if you're sending the data from Cassandra, you can transform that data using the pulsar functions in a real time and send to the downstream target. For example, you want to send particular columns, only few columns to the Elasticsearch for search. You don't want your Elasticsearch index to go big in size. You want only 6 out of 5 columns. You can do a pulsar function. You can remove the columns, do some transformation of the data, and then send data to the Elasticsearch. So with this, you can, with pulsar functions, you will be able to do almost 90 to 95% of work, which usually we do using the Lambda functions. It is very supportive. It supports a lot of languages. You can write it in Java. You can write it in the Python, or you can write it in any of your other coding languages which you can do. And then sinks here means the destination where you want to send the data. So we can have, we support almost every sink. So by default, so some of the tested sinks are here. So some of the sinks which you don't see here are also available, but you need to do some extra effort because you need to create manual configuration for those, because we keep on adding slowly all the sinks after testing when all those sinks, different type of sinks type. So this is the traditional how we play with an Astra streaming. Now quickly coming to a demo part. So what I have done, which I was trying to show you an example. Now what I have done here, so if you see my streaming engine here, I have already one workspace streaming, and what I have done, I have created 2 sinks. So first sync, if you see, I am sending as per the diagram. I'll quickly open that diagram also so that we can relate to it what we are trying to do. So I am sending one sync to the Elasticsearch and one sync to the AstraDB, and there's a function value proximity which will push the data to the particular push message. So what I have done here now, so you see that this is the Elastic sync which I have set it up. So simply given the location of an Elasticsearch UI, which is here, and then the credentials for that Elasticsearch where I want to send the data as a downstream target quickly. And same way, I have created one more sync, which is an AstraDB sync, where the data will be sent after getting into the topic. It will send to the downstream target of an AstraDB. So this is the particular configuration for that also, which is given out here. And there is one function, which is a value proximity function, which is written in Python. If you see what it does, it calculates the value proximity of particular, what I can say, that message which comes here. So I'll show you a real time how it happens. So I have 3 different set of codes here if I talk about. So this is the first, my script which will, Python code, which will wait for the messages. Whatever message I send to it will read the messages which are coming. And there is one more stream consumer proximity code. 1 second. There is the stream consumer. So it will this code will consume the streams of the message. So it is also given out here. And the third one, where I push data in a dummy fashion to the server. So for example, if you see here, I am trying to send data to the server using some entity ID. For example, this is an EID which I am doing. So for example, now I'll choose some EID now. So I have chosen, for example, 2 lakh as a EID now. I will quickly write this and then quickly let me save this. So now if I run this particular, let me run both the codes again. So it's connected to consumer. So if you see with that EID 20,000, it has already sent a message here. So now this message is gone into the streaming engine. It comes here also at the venue proximity. This function is calculated venue proximity. If you see, it has given me that Get Your Coffee is the nearest restaurant which is available to this particular, what I can say, that store. So this is how, with in a real time, we are able to do the calculations, which is the nearest store available to that particular point. And same thing, if I want to check at an Elasticsearch also, I can quickly go and do that also. So let me, sorry. So here, if I go, this, I can edit, I can just add a filter, set filter, EID equals 2200, set filter, save and close. So then I'll go and refresh it. So it should be available here in the application. 1 second, sorry, I need to zoom. Oh, yes, I think that is an issue. So 1 second. Let me so I'm editing the filter. I think I did 2 lakh. So this is the place where that particular user is located, and if I zoom it out quickly, I can show you in more detail. So this is sorry, it's getting. So this is a user which is located here at this particular location. If I more zoom it out, you will find which will be the more nearest restaurant to it. So this is Wired Cafe, which is nearest business to it. So this is how you can quickly build a real-time, not only, we only know the data stack about the data at rest, which is Cassandra, but we have done a lot of development in the data at motion with the Apache Pulsar as a technology, and making it a serverless and auto-scalable, which gives a lot of flexibility to handle a lot of data. And at a single platform, you can build a complete application or a real-time kind of an application or real-time recommendation engine for your customers. I hope this suffices.
All right, that was really a very clear guidelines from Mr. Chirag Shah and a great demo from Mr. Jonit Singh. Can we have a huge round of applause once again for them? All right, so from the bottom of my heart, I'm gonna say all these words and the very true one. Looking at this wonderful crowd out here, I was really surprised to see everybody's presence here was so electrifying, so energized, and so much attentive. Thank you so much for being here and making this event very colorful and very successful. Please give them a huge round of applause, one and all present here. And to present the word of thanks, I call upon Mr. Henry Isaac. Please come up on the stage. There is no end. There are some more activities. You have to be here. Please stay tuned with us.
This is just the beginning, right? We are new to India. I mean, we are just 1.5 years here. But thank you for all the support and the encouragement given. I'm highly honored seeing you all the support that comes in. We are. Thanks. So a couple of things. One is there's a QR code that will be coming on the slide. If you can just fill up the Google form, that will help us. We as a company believe in partnerships. We together have to make this world a better place, especially in the world where we are. That's the data world, right? So anything that you want to contribute to this community, I don't know how many of you are aware, we contribute around 70% plus to the Apache Cassandra, right? And now we are doing a lot for streaming. That is the way how we give it back. And as my colleague was mentioning, right, a lot of things are coming from India, especially the developers. So how can we together maybe run a community here in Bangalore? Happy to hear your feedback around it, so that we can meet more often. I want you guys to drive it, and we are there to support, right? So it's not about us, it's all about we all doing this thing together. And thank you so much. If you can just take a QR code, 69. Yeah. If you can take just a picture of it, you'll get a Google form. Please give your feedback. And thank you so much once again. There is a lunch serving for you all. And I'm thankful to my colleagues who have come from Singapore, like Alan and Joyce, who run our marketing. And also to my colleagues who have put together awesome demos, and to the couple of Suresh and like Rakesh to come up and give their experience, sharing their experience together. And thank you so much. That's it from my side.
Yeah, thank you so much, Mr. Anji. I request you to please be here. I request DATASTAX team to come up on the stage. All the data team, please, DATASTAX team, please come up on the stage.
So after this, you all can join, and we'll take one picture too.
Very successful with their great presence. Yeah. And one more thing, dear audience, if you guys have liked this show, right, it was so educating. So if you're really thankful, please stand up and clap for our DATASTAX team. Thank you so much, dear ladies and gentlemen. Presence was really great, and really thank you so much for the DATASTAX team.